Welcome to the Explainer. Today, we're going to break down one of the most fundamental concepts out there, not just in statistics, but, well, in life. We're talking about probability. It's really the science of uncertainty. And once you get the basic rules, it can totally change the way you see the world.
All right, let's kick things off with a question. Now, it might seem pretty simple, but it actually holds the key to understanding how all this works. What are the odds of drawing a card that is both a queen and a heart? We're going to unravel this together, and I promise, by the end of this, you'll see just how straightforward it is.
Okay, so to even start answering that, we've got to make sure we're all on the same page about what statisticians actually mean when they talk about odds or probability. And it all boils down to this one idea: the long run.
So if you look at the official definition, probability is the likelihood of the occurrence of an outcome over the long run. And listen, those last three words, they're the absolute key to unlocking this whole thing. See, probability isn't really about predicting a single event with 100% certainty. You see, this long-run idea is it's so crucial because it helps manage our expectations about randomness. Think about it. If you draw one card from a deck, does that 25% probability mean it's definitely going to be a diamond? No way, of course not. But if you were to draw a card, write down its suit, put it back, and do that thousands and thousands of times, the percentage of diamonds you pull would get incredibly close to exactly 25%. It's why we don't fall for things like the gambler's fallacy, that silly idea that if you get heads 5 times in a row, you're somehow due for a tails.
Okay, so we've got the long run down. Now, let's talk about the rules of the game. Just like any good system, probability has a few strict, but honestly very logical principles that kind of set the boundaries for how we can even talk about chance. So, rule number 1 is all about setting the boundaries. Think of it like a scale. A probability can never, ever be negative, and it can never be more than 1. If an outcome has a probability of 0, it's impossible. Think rolling a 7 on a regular 6-sided die. Not going to happen. And if an outcome has a probability of 1, it's an absolute certainty. Everything else, it just falls somewhere in between. And then there's rule number 2. Basically, the probabilities of all the possible outcomes have to add up to exactly 1. A coin toss is the perfect example, right? The probability of heads is 0.5, probability of tails is 0.5. You add them together, you get 1. This rule just makes sure we've covered all our bases. Simple. You know, there is this quote from S.K. Ketchigan that I just love. It is better to be approximately correct than precisely wrong. And it's such a great reminder of what probability is really for. It is not a crystal ball, right? It's not for making perfect predictions. It's a tool, a really powerful one, for being thoughtful and, yeah, approximately correct about uncertainty. And that is so much better than being super confident and precisely wrong.
All right, so we've got the theory down. How do we actually, do the math? Let's get our hands dirty and put some of this theory into practice.
It's actually a super simple 3-step deal. First, count up the number of ways your desired outcome can happen. Second, count up all the possible things that could happen. And third, you just divide that first number by the second. Desired over possible. That's really it.
So let's use a classic example to walk through this. A standard deck of playing cards. It has 52 cards total. Okay, that's our number for all possible outcomes. Now, let's say we're interested in drawing a diamond. We know there are 13 diamond cards in that deck. That becomes our number of desired outcomes. Okay, now for the easy part. We just plug it into the formula. We take our 13 desired outcomes, the diamonds, and we divide by the 52 possible outcomes, the total number of cards. So that's 13 over 52, which, simplifies to 1/4, or a probability of 0.25. See? Simple as that.
But, life is rarely that simple, right? What happens when we care about more than one thing at a time? This brings us all the way back to our opening question, and it introduces the really important difference between and or.
So for situations where you need 2 or more separate things to happen together, and independent is key here, meaning one doesn't affect the other, you use something called the multiplication theorem. You just figure out the probability of each one by itself, and then you multiply them together. And boom! This is how we crack the code on our opening puzzle. The probability of drawing any queen is 4 out of 52. The probability of drawing any heart is 13 out of 52. We multiply those together, and we get 1 out of 52, which makes perfect sense, right? Because there's only one queen of hearts in the whole deck. Okay, But what if you're looking for a queen or a heart? For that, we use the addition theorem. We start by adding their separate probabilities. 4 out of 52 for a queen, plus 13 out of 52 for a heart. But wait, if we stop there, we've made a mistake. We've actually counted the queen of hearts twice, once in the queen pile and again in the heart pile. So we have to subtract that overlap, which we already know has a probability of 1 in 52. That gives us our real answer, 16 out of 52.
Okay, so we've covered single events, and events, or events. But let's be real. Outside of card games and flipping coins, why does any of this fundamentally matter?
All right, let's do a quick recap of the big takeaways here. First, probability is always a number between 0 and 1, and it's all about predicting what happens over the long run. Second, we use multiplication for and situations, and addition, remembering to subtract the overlap, for or situations. These simple ideas, they are the absolute bedrock of modern statistics. You know, the material we're pulling from for this explainer, it's all about the pharmaceutical world. And it really highlights how these exact principles get used every single day to make literal life or death decisions. From making sure every single pill that comes off a production line is safe, to figuring out if a new drug actually works in a clinical trial, it all comes back to having a rock-solid understanding of probability.
And that really brings us to the biggest takeaway of all. Probability isn't just some abstract math concept for scientists. It's a mental model. It's a tool for thinking more clearly, more rationally about a world that is just full of uncertainty. So the real question is, now that you know the basics, what uncertainties in your own life can you start to quantify?